the video. My name is Aman Pori, and this is for public lecture review number 2. And the debate is, do we live in a simulation? This debate involved these professors from all over the College of Computing, the physics department, and also the philosophy department in addition, as well as there is a neuroscience instructor as well. So this is the debate that's at discussion. Do we live in a simulation? Obviously, this would be a computerized simulation with programs running and algorithms, and that is kind of the lens that this discussion goes through. This is public lecture number 2, Do We Live in a Simulation? This discussion was actually very interesting. There were a lot of things that I learned that I didn't know, a lot of terminology used by both the audience and the professors, as well as even the moderator, who was a fourth-year physics student, I believe, and all credit to her. But first, do we live in a simulation? So this discussion consisted of these 4 components. Primarily, one is obviously the computing power and energy needed to power such a simulation. The next is philosophy. Why would someone want to put us in a simulation or simulate a different reality than their own? And what would that involve in terms of ethics and how malicious people can be? The next is neuroscience. So there was a neuroscience professor that discussed the limits of neuroscience and how that can affect what we might think as an impossibility with simulating the human brain and its components. And then last is the most relevant to me because I'm a computer science major, but it's computer science and artificial intelligence. So obviously, humans have already been trying to simulate consciousness or reality in computers, and there were a lot of good points made in this argument that we'll discuss in a second. Within the first component, there were a lot of theories that were discussed. So this is one thing that I didn't know, a term that I didn't know, and it's a Dyson sphere. So it's a hypothetical megastructure. Obviously, humans are not capable of building an entire structure around a star, at least not at this point. And this megastructure would harness all of the energy from a star, and there are some numbers that do relate to this that we will discuss, but basically we're discussing how Dyson Sphere would be able to power the computing operations of a computer. No, that was mentioned was what a Turing machine was, and this is basically a mathematical model of how a machine can simulate another machine of the same power and run the same algorithms if it's capable. It's not a real construction in real life, but it does hold up mathematically and theoretically that there is a machine that exists that can emulate another machine with the same power. So basically, in regards to it being in a simulation, that we could create another reality that simulates the one that we're in right now. There is the capability of machines or computers to replicate the abstraction of humans. So another thing that was mentioned was the Nikolai Bernstein experiment, he was a Soviet neurophysiologist, and he taught a kid how to draw a circle with his fingers first, and then asked the kid to then draw it with their hands and feet, and the kid was able to do this, while with a computer, with giving it in specific instructions, it's not able to abstract at the level of human consciousness, which is something also to consider in a simulation. The most relevant aspect of this conversation to me was the discussion about computing, and as discussed earlier also in regards to physics and energy, there are some mathematical calculations that we can do from the power of our sun, and how powerful the most powerful processors are on Earth. So a simulation of all reality on the planet would take 10 to the 39th operations per second as calculated by the math professor who was on the panel. And using a Dyson sphere around our sun and our solar system, we could harness 10 to the 42 operations from the sun. Now, the math professor also argued that this would not be enough despite it being magnitudes larger than 10 to the 39th. But for comparison, the most powerful computing processor on Earth can do 2 times 10 to the 18th operations per second. So the limits for cooling and energy loss make it impossible for our realm of technology and how far we've come. But maybe not perhaps for another species out there in the universe.